Okay, hi, good morning, everyone. So yesterday we heard various industries. For me, it was very interesting, and today I'm going to talk about a big industry, which is the construction industry, and to explain why it's so important for this industry to reach zero carbon. So we talked about humanity's perhaps greatest challenge. Nobody benefits from climate change, but since so many changes have to be made, there are potentially huge opportunities to do things better, to do things different. Things cannot stay the way they did for hundreds of years in all industries and specifically in the construction industry. So previously we needed the images of polar bears. We don't need them anymore. It's here. Climate change is understood, I think, by the general public. Of course, we know it, but the general public also now understands that action must be done. And the Paris Agreement, and we hear noises now regarding the Paris Agreement, but the world is moving towards keeping the 1.5 Celsius, and for that we need to reach zero carbon in many sectors, construction sector as well. And again, why the construction sector is so important? Primarily because of the fact that it's the biggest carbon emitter. Almost 40% of global carbon emissions come from the construction sector, 28% from operating buildings, and 11% from the material extraction, manufacturing, installation, etc., etc. So in total, almost 40% of this is from the construction sector. And again, in order to reach the 1.5 degrees, it's crucial that the construction sector zeroes its emissions by 2040. So we already started the journey. I think 10 years ago, it might have seemed like science fiction, but today I'm going to show you that it's happening already, that buildings will not produce CO2. And again, it's an opportunity to make much better buildings than we used to make. I think it's encouraging to see, while we still hear about legislators debating, it's really encouraging to see that the commercial sector is really stepping in. And I think that today, if you go into most websites of big corporates, you'll see their commitments to zero carbon. And I can tell you, these are some of our clients, and they're not just writing it in the website, they're actually doing a lot. And if we take Microsoft as an example, and this is from their ESG report, then they are working for several years with a multi-year roadmap. Obviously, they're putting their emphasis on the chain carbon emission. So the scope 3 is, of course, the biggest challenge. And we see already how they begin to reduce it. But they're also investing a lot in carbon removal. So they aim to be carbon negative by 2030. But by 2050, their goal is to remove all the historical carbon since they were founded in the 70s. And I think this is really to show us that there is a demand, the market, and certain early adopters in the market. Obviously, it's not the whole market, but the early adopters are looking for these solutions and products that will take them to zero carbon. Alpha is a small company. We're doing building science, so we're architects and engineers, and we're fortunate to be involved in some of the highest profile projects in Europe, Africa, and the Middle East. Typically, we certify the projects that we're part of to LEED standards, so the highest LEED standards, which is platinum. but we already have some projects which have been certified to zero carbon, and I will talk about them today. So the first case study that I want to show you is a building in Israel, in Givatayim. It was built around the 80s, and you know, one of the biggest problems for a developer, a landowner, to do a retrofit, to upgrade his building to be more energy efficient, is the fact that the building is never empty. Because if a tenant would leave, let's say, one floor or two floor, the other floors are still occupied. And therefore, it's very hard to do major deep renovations to upgrade buildings. And perhaps one of the biggest players in achieving net zero are the existing buildings. Because in 2040, when the entire construction sector must be zero, 60% of the buildings are already standing. So the challenge is to upgrade the existing building, and this is an example of an upgrade to an existing building. In this case, there was, again, a big opportunity because it was a single tenant building, and the tenant left, and therefore the developer, Amot Real Estate, who has the vision, who understands that they need to be in the game of zero carbon. So they decided a strategic decision based on our recommendations not to tear the building down and leave it structure and envelope, and rather upgrade it using the existing structure, and therefore we'll see in a minute benefits that they really gained from this decision. So in order to do the retrofit, they hired Sasaki, an architectural firm from Boston. And Sasaki did a lot of work on the design of the envelope to really think out of the box how this building might look like with a deep renovation. Eventually, they chose the ribbon option. And this was meant to really give the building a whole new appearance and practical improvements. We did a lot of work with Sasaki and the developer to really optimize the envelope so that it will shade the facades, it will enhance daylight, and it will produce renewable energy. So this work was unfortunately scrapped due to zoning. So again, this was a relatively low budget project, and we had to stay within the zoning requirements in order not to ask for a new permit, and therefore eventually the building got a new envelope, but not the envelope that we planned in the beginning. Still, it was a major improvement to the old building because it allowed us to integrate many improvements, such as enhanced daylight for the interior spaces, a new HVAC system, much more efficient. We collect all the condensation water from the HVAC and use it for irrigation. And perhaps the most two special items is that by leaving the structure and envelope of the building, we saved an enormous amount of embodied carbon. I'll show this in a minute. So that's one interesting thing. And the other one was that the facade now is a renewable energy production facade. So it's producing energy right now. The building was the first in the country to be certified to the new version of V4. And again, this is a major asset to the developer. And now it's in the final stages of the zero carbon certification. We completed the requirements and are waiting for the final audit. So this building will be a zero carbon building. How can you make it? How you do such a zero carbon certification? So first of all, the interior, I don't know about you, but I don't seem to like the right slide of working in such an open space. So this old interior was replaced by a much more appealing interior, as we can see from this slide. So again, there are several mechanisms for certifying third-party verification and certification for zero carbon. The International Living Future has been around for 20 years. It's not new. And so it's a well-known brand for certifying buildings to zero energy and now zero carbon. And it requires you to excel in two categories. The first one is the embodied carbon. The building has to be better by at least 20% from a benchmark of 350 kilograms of CO2 per square meter. Just to give you an idea, I assume that most of the buildings here around us are somewhere between 500 and 1,000. If they're concrete buildings, that's probably the amount of carbon that is in the structure. So improving 20% from 350 is not easy. But since, again, we kept practically the entire building structure and envelope intact and didn't demolish it, we achieved an amazing 90% reduction because our benchmark was what it would take to build a new building with new concrete. So this is intentionally to encourage developers and landowners to use existing buildings instead of demolishing, which is sometimes, you know, the first thing that comes in mind. We'll demolish the building. No, it could be more cost-effective to leave it and to use it. And definitely, regarding sustainability, it's much more sustainable because we're saving all the concrete that should have been used for a new building. So again, here the 50 kilograms of CO2 per square meter are practically new windows and new aluminum, advanced windows for the facade, but again, it's a very low number. The second item that the building has to excel in is the operational carbon, which means energy bills. So we collect energy bills for 12 months, and we have to be better than a threshold and a benchmark of ASHRAE 90.1, which is the international standard for energy. And working here with the operation and maintenance team, without doing too much, infrastructure improvement, we achieved 35%. Whenever you can work with the operations and show them your score for operating the building, they're pretty wise regarding the systems. They can run the HVAC an hour later. So they have a lot of flexibility to improve the performance of the building, but you need to monitor the performance and to give them feedback in order to improve. Regarding the envelope, the initial thought was to keep the marble, the brown reddish marble, but it was understood that scaffolding the entire building was very costly, so they decided to leave it, and it was again an opportunity to improve the thermal insulation and to add the BIPV, which today is a system that is integrated into the facade, so it produces electricity, and you can get it in various colors, so architects really like to use it. And here in this slide, you can see that this part, the gray one, is actually producing electricity. It's the south facade. So all these panels are producing energy, as you can see in this animation, during the day. So when the sun comes up, this would obviously work much better. The northern that we go from our long latitude to Berlin, for instance, it would work much better here because of the angle of the sun. and obviously it works better in the winter. Okay, so for the first project, we measured our embodied carbon, we improved our energy efficiency, and we produced renewable energy. But for the next project, we really enlarged the scope, and we looked at the entire scope 3 of the company, and therefore we chose Global Network for Zero as a platform, as a third-party verification. And we did our own office, and I'll show you this in a minute. So the Global Network for Zero takes scope 3 into account. So all the emissions associated with the building, but not produced directly on the building, are also calculated, like transportation and construction and waste, etc. So this also goes into the calculation. And the platform, again, is built so that buildings will be able to be certified by removing scope 1, 2, and 3, and improve the space, the interior space, the well-being, physical, mental, and social well-beings of the occupants. So again, it's not only about carbon, it's about making better buildings. That's very important to understand. And again, this platform recognizes the improvement in the building. The system is divided into categories, so we have wastewater, energy, and emissions. And it's also flexible regarding the timeline. So we can certify the design, we can certify the construction, we can certify the operation, or we can do all. It really depends what's best for the owner. So this is the campus. It's our own campus, and we decided to invest in it in a way that would make it zero carbon. So the building itself, again, was built in the 80s as an agriculture building. And when we moved in, we made various adjustments, and I'll show you this in a minute, to make it possible to certify it to zero carbon. So the space itself has a lot of daylight, a lot of views, open space with working areas. It's not a big office, of course. It's a very small office. Practically the entire new structure was made from wood, and by that we reduced a lot our carbon footprint. We used a lot of reused equipment, furniture, etc. And regarding the sustainability features, so we do have a photovoltaic system, of course. We collect all our condensation water to use it for irrigation. And we added a unique feature. We collect all our organic waste and use it for biogas. And this, again, opens an opportunity for something that didn't exist before, but it's a social phenomena that for 2 times a week, we have lunches which are cooked on biogas. And again, this is something that the staff really likes and is working amazingly. Here you can see the system itself. It's made by a local startup. Very simple, no electricity attached. We rent it, so it's not ours. So we just pay a monthly rent, and it's very cost effective. And really very simple because it saves us the need to transport all our organic waste, which is 60% of our waste. So this is organic waste. And the next important feature is the communication to the occupants, to the staff, because this is something really big. You can have the best building ever built, but if the users will not be on this journey, then they'll use electricity 24/7. So the engagement to the users is really important. And therefore, we designed in the center of the space the dashboard, and dashboards are very important to see in real time, not 2 months after when you get the bill to see in real time how your building is performing. And again, it's not very sophisticated, it's quite simple, but we do have the air quality system here, we have the energy consumption here, and we have the energy production here. And this allows us to interact with the users, and sometimes we get messages, someone left the HVAC working after working hours. So it becomes, again, a social phenomena as well. So regarding real-time equipment and sensors, again, we're using a local startup called Radgreen, which is monitoring the air quality of the space. And these are very simple sensors that you plug in the socket. You don't have to wire them, but they give us the information about air quality. And what's more important to the users than air quality, the amount of CO2 in the space, the amount of VOC. So again, this impacts the well-being of our staff very much. They know it, and they're part of it. And again, it allows us to make sure that the space is running at a high standard. So going through quickly the assessment itself. So obviously we had to collect all the information regarding Scope 3. And again, we found, like in other organizations, it's the biggest emitter of the CO2. In our case, 91% of our emissions come from Scope 3. And doing the process for a small company is much easier, I guess, than for a big company, because our chain is only our activity. But still, we had to look at all our operations, like we had to do a waste survey, we had to do a transportation survey, we had to assess our HVAC equipment, look at the refrigerants, and again, this was an opportunity to improve. So what we did in order to reduce was we changed our small fleet of cars to electric cars, and this had a major impact on our Scope 3. We changed refrigerants, again, it saved us money. And we added the biodigester, the biogas, as I just mentioned. And that left us with offsets. So we decided to do a combination of IREX and carbon offsets. IREX for Scope 2, we registered our own system. So most of the IREX came from our own system, which is great. We didn't have to pay for that. And regarding the carbon offsets, we did it by a local suppliers, a Porto Carbon. So we were able to choose the projects going for offsets and make sure it's local, real projects that we can audit. So we got the certification in the early 24, the early beginning of 24, but it didn't, and there the construction cost, and here you have the construction cost and certification cost. And I think what's really striking about this slide is that it's a really, really low budget project. So I think $440 per square meter is pretty good. And again, it allowed us to achieve a really high performing space and to certify it to zero carbon. So it means it doesn't have to be something only the Microsoft and Google are doing, but a small firm of 25 people can do it as well. So the process didn't end. We're still going ahead, and we chose to do an annual verification and to see how we're performing as we go on. And again, it's an opportunity to improve your operations. We didn't have to do it, but we chose to do it. Okay, so we're looking ahead, and now assessing the energy. Over the last year, we found that by doing this assessment, we got very big savings. So again, it's opportunity to save even more, and we really lowered. These are big numbers. I don't expect I don't expect any company to reach such big improvements, and I guess it's very easy to do that, or relatively easy to do that on a very small project like ours. But the numbers really are astonishing here, because we did get a lot of improvement regarding energy reduction and carbon emission reduction from commute. We ran satisfaction questionnaires, and again, this is something which I'm really very proud of, especially this line here on the bottom, that you can see that there's about 20 participants in this questionnaire, but all of them felt that the space really contributed to their health and well-being. And this is amazing because, as I said, carbon reduction and zero carbon is the spearhead, but the true benefits are waiting behind in the opportunities that you have to improve your space. And I think this really proves it, that we got an excellent space, which is also zero carbon. So my last slide is, again, the change has begun. So buildings will go and on this path of zero carbon. There's two options, I think, for all of us. One is to wait for the governments to decide where they want to go and what they want to do. I don't think that's a good option. And the second option is to start the journey. And it could be an intimidating journey. It sounds intimidating, but the first step is really, really very simple. And it requires an assessment of zero carbon. You simply measure your footprint, and I'm not sure how many of you in your organizations did that, but once you do it, you're on the first step to continue the process to do a long-term plan and eventually to do the certification. And as I said, you're doing a very important thing for your own business and for, of course, the global construction industry. And I think that's very important to do, and it's a must to do today. Thank you very much. If there are any questions, I'll be glad. Yes, please.
Hello, Charlie from Glamworks. Thank you very much for the presentation. You showed some numbers, so 90% of embodied carbon reduction with refurbishment and 30% reduction of operational carbon, right? So the future really seems, the future of construction really seems to be in the refurbishment, but what are then really the roadblockers preventing those? Because I can see very few examples in major cities of refurbished buildings so far.
Okay, it's a great question, and I think again it's in the mindset. Of course, there are structures that are very old, and they're regarding safety, you have to tear them down. I'm not talking about those unless there's a cause to strengthen them structurally. But what we see now after this first case study that I showed you, that it opened the mind of developers because they have existing buildings made of concrete, and in a building culture, which is building good buildings and strong buildings, it's a waste to tear them down. So it's true that we don't see them a lot, but I think many of the reasons are psychological reasons and not practical economical decisions. So what I would recommend is to have an audit by a structural engineer for a building who needs to be torn down, let's say. The structural engineer must answer if this building is still safe and it's still worthy to be kept. And I think the answer would be in many cases yes. Okay, and once it's done, you get once you did it, you get a major environmental benefit by not tearing it down, because to reach it with other materials would be very, very difficult. And whereas you left the structure, you saved a huge amount of CO2. So you start from a very good starting point, and now you have to make sure your envelope is energy efficient, you have thermal insulation, etc. But that's easier with the technologies that we have today.
Are there also some numbers you can share in terms of cost savings, or how much cost has been saved? And finally, also, what would be the split, you think, between refurbished or recycled buildings and new construction? Like, what split do you see by, I don't know, 2050, for instance?
Regarding operation costs?
Regarding, construction in general in the future, would be 40% refurbished versus 60%, for instance, new construction, or like virgin buildings, or?
Okay, so you asked a few questions, but regarding, let's say, operation costs for the first project that I saw, I don't have those numbers because the tenant is a totally new tenant. The previous one didn't have data centers. The new one is a high-tech company with a huge data center, so obviously it's using more energy. So it's very hard to compare. But I showed you our data from our office, and again, regarding operation, it's a no-brainer. You get a better building, you get a more insulated building, so your operating costs are lower. And regarding the costs, again, I showed only our construction cost, and it's hypothetical to show it against a benchmark. Like, we didn't do the other project of building a new building, right? But I would assume that, again, using the structure is much less costly than building a new building. I think that's common sense. So again, I would look for those opportunities to leave the existing structure to save also money, not only carbon. Yes?
Yeah, thank you so much for the presentation. It was really, really, really interesting. I have a question. So you said earlier that this interest to do all of these things is driven by companies mainly, right? You showed Microsoft, you showed Google, you showed many great companies. And I lived in Singapore before, and I was blown away when I lived there. I was very young. I was like, this was very new. I was really blown away because it was so modern for me. And so I wonder, for sure, it's also driven by cities, right? They want to decarbonize. And so I actually have two questions. The first question is, which cities do you see on the forefront of doing that? Is that Singapore, Copenhagen, whatever these cities are? And then the second question is, how do you see this developing? Like, which cities are really up and coming? Is, I don't know, like China, for instance. I know that they want to decarbonize, really hard as well because, they have issues with air quality, for instance. So, how is this developing in, let's say, the next couple of years? If you could talk about that, that would be, really interesting.
Okay, so, I don't want to give any crazy assumptions because I don't really know how the Chinese market will act, but I can say that currently the number of zero carbon buildings is less than 1%. Like, it's very, very small. So we look at it at case studies which could be a vision for other projects. And I think more and more now, with understanding that this sector has to cut emissions and regulation, this is the right way to go. Because again, it doesn't cost you more. So I think again that the psychological barriers that we saw over the last 10, 20 years are beginning to disappear because people understand that there needs to be a change. You see the big corporations understanding that very well. Not only them, the developers. The big developers are now understanding they need to have a space which they can lease, a zero carbon space. We heard about, again, Google in London, that they certified their whole headquarters to zero carbon. So this is now becoming a requirement in some markets, not all markets, but some markets in Europe are requiring zero carbon. when we see an RFP of an international firm, it has very stringent requirements regarding carbon reduction. So I think, again, this is the right thing, the right path to go. It'll only grow from now. And the very small percentage of buildings certified to zero carbon will, I think, over the next 5 years, will grow dramatically.
And sorry, just one more question about this. So thank you very much for your answer. Is there any city in the world that is pushing this agenda? Is there any, I don't know, like, is it Singapore? Is it any city that is really thinking about this and really trying to have, you know, the companies do something about it? Or is the city really, you know, laissez-faire, like they don't mingle with that and they just like let the companies do? Or like, you know, like, I just really want to understand if there's any like city out there in the world that is actually really pushing that agenda, because I think it's awesome.
Again, I don't know of a specific city. I can tell you about Tel Aviv, for instance, that in order to get a permit, you need over 40 stories high. You need the building to be LEED Platinum, which is the highest LEED. So you do see requirements, very stringent requirements from cities and municipalities. The C40, which is led by Paris, is pushing for zero carbon. So how is it going to do it? If not, to require buildings to be very, very energy efficient. So I'm not sure that the regulator is ready for zero carbon mandatory. And I think case studies like this would make it more assured that he can regulate such requirements. But again, definitely it's the path that we're going. That's my opinion. More questions, please?
Yeah, I've got a question. Good morning. Thank you very much for your presentation. So just looked up the temperatures in Israel. They're like between 9 and 40 degrees. So the HVAC system is a suitable solution for heating. When we look into the northern hemisphere, like Norway, they're improving their district heating infrastructure, but they are pushing this really hard. So countries like Germany, like Sweden, Canada, a biomethane solution might be suitable, but if everyone wants biomethane, the prices are going to explode. So my question is, what do you think would be a suitable path for companies to decarbonize those facilities under the circumstances that biogas is limited?
Okay, so again, it's very place-oriented, so the solution needs to be local. Renewable energy is very vast. In some places, of course, you have wind. Also, now I think the understanding is broadening that you don't necessarily have to have the renewable energy on your roof, because if your grid is 100 or 70% renewable, that's great. And you know, IREX is something that you can invest and buy in a different location. So for instance, now that we see municipalities requiring, in order to get a permit in our country, they're requiring the developers to have 5% of their energy consumption out of renewable resources. They don't require it to necessarily be on the roof. Okay, so if you can buy renewable energy by IREX, it's just as well regarding renewable energy, which if you'll install in your roof might be too tight and not work very properly, if I'm making myself clear. So again, it's renewable energy is looking for the right opportunity, and even if it means purchasing it, it's a right opportunity if it makes sense financially. Energy saving is something that needs to be also done. And again, with an existing building, it's sometimes more challenging. The old buildings are less insulated, and it would be more costly. But again, you're saving a lot of money on the structure, so you might as well put it on the insulation to make your building better. But what I'm saying is that it needs some kind of design. You need to look at the specific requirements, at the specific opportunities, specific technologies, to integrate it correctly. So definitely a certain design must be done. And I would also say that the challenge with existing buildings is that every building is different. It's very hard to scale up and give a a single answer for all existing buildings. It doesn't work. So part of the struggle here is to come to a building to understand how it's operating and to see how we can improve it and do it in a cost-effective way.
Do you have any projects in the northern hemisphere where we have like temperatures below zero? Have you done some projects?
Sure. We did a project in Munich, LEED Platinum. So it's a fit out of a few floors, but they did install PV on the roof. It was for Microsoft. And the platinum there was achieved by various aspects, including very efficient HVAC for the interior, sensors for lighting to shut off lighting when they're not used, etc. And so this is again possible, of course, in the northern hemisphere.
Yeah. So I guess the heating was partially also done by gas, I assume. So it's a hybrid system.
I don't remember exactly how the heating was done. I can look into it.
Yeah. Thank you very much.
Thank you. More questions?
Hello, hello. Yeah, I have a question. I'm Sergei Nemodin from Volkswagen AG, and thanks for the presentation about the buildings. We're also looking into this topic, and I have a chance to present it later today as well. So I have two questions. Out of your experience, so we talked about the government or let's say state requirements, in terms of buildings, what has to be done to be compliant. But like on the other end, out of your experience, is there any incentives in the markets available, to support this activity? Yeah, maybe you mentioned you worked in different markets, so how would you, let's say, estimate this trend? And the second is more specific question. You also mentioned PV facades. So my question would be, how mature is this technology, and price-wise, how it is compared to standard regular roof
Sure.
construct installations?
Okay. So regarding the incentives, we've been talking here with my colleague. It's an opportunity, another opportunity, because I think in Germany there's not hundreds, but maybe even thousands of programs, and you need to find the right program for the right project. So definitely you need to do on it some work and thinking. If you ask me personally, and I'll say here something from my own perspective, I wouldn't even wait for these incentives, because I think, again, I talked about the benefits, and I'm looking at our very small project, again, with cautious. We have to be modest with it. It's a small project, but I didn't do it with any incentives, and I didn't look for any incentives, because the benefits are there. They're not only energy, it's simply being in a better building, better for your health, better for your comfort. It's sometimes hard to quantify, but they're real benefits. So I'm saying, again, I recommend to look at it without concern for incentives, to look at incentives, of course, as a bonus. And I'm pretty sure in what I understand in the German market, there are various programs that you need to find out. So this is for the first question. Regarding the second question, so obviously the technology is more expensive today. If we look at the return on investment for rooftop systems in our climate, and it's different in Germany, but in our climate, the ROI is amazing. It's 4 to 6 years with an interest rate of somewhere in 16% interest rate. So it's better than putting your money in the bank. So that's for the rooftop. Regarding the facade, it's a question of the cost of the system and the efficiency. And since we're closer to the equation, we get less sun in the summer because of the angle, and more in the winter. So again, as I said, in Berlin it will work better. But still, the ROI is around 12 years. And what's happening, because now municipalities are requiring developers to integrate BIPV, there's a local manufacturer. That's what happens to the economy. When there is a requirement, the economy is there. The industry is there. It needs clients. So the more clients, we see it happening. The price is going down, the efficiency is going up. There are various systems for European manufacturers. In Spain, there are some very good manufacturers of BIPV. And you know what I'm telling developers is that it's also a question of area, because they can be in the game, in the ball game of BIPV, of building integrated photovoltaics from the facades, not necessarily with 10,000 square meters, but with 100 square meters. So they can do a pilot on a small area to see how it works, to feel more comfortable, and then to enlarge it. And by that, the later they do it, the price will go down. So I think, again, it's something that should well be considered. More questions?
Yeah, thank you. Maybe just to add to that, how about the Middle East? Because like climate-wise, I think it's pretty similar to Israel. Is it also coming there?
Yes, definitely. And we see also in the Gulf, Dubai and other countries are integrating. They're very, in general, they're very fond of new technologies. And we see more and more requirements for BIPV. So definitely it's in our area the #1 renewable resource, which is practical and cost effective. More questions? Thank you very much.
Thank you very much.